Can anyone differentiate the numerator for us? So the denominator will be just squared. Can anyone differentiate the numerator for us, please? Please. Yes, very good. That's it. Awesome. So then I copy 3x squared minus 5x. Can anyone differentiate the denominator for us? Awesome. These problems should be, this particular problem should be, or rational function should be simplified. This one maybe not, maybe, but here we should distribute. We should distribute combined like terms and so on and so forth. I'm just going to put so on and so forth so we can move on and touch up on all of these problems. Okay, so let's look at page 179. 35 and 13. 35 and 13. Since we, so 35 on 179, what was it? Yeah, we already did a problem like that, so I can skip this one. So this was s of t equals t cubed plus t. So the velocity and the acceleration, and evaluated such and such. I think we should skip that because we already did two, or at least one tonight. And let's see 13. What did I want with 13? Yeah, let's do 13 again. So we have f of x equals x to the fourth plus 3 over x. They're asking us to find f prime and also f double prime. Can anyone give us f prime for this function? Anyone, please. I want to make sure that we touch up on all these problems, and then we'll go back if we have.
X to the third.
Thank you so much.
Minus 3 over x squared.
Brilliant. Thank you so much. Now the next one. Now for this one, when I differentiate again, I have to write it like this. This is a must. For this one, no, because I have a formula or a rule carved in stone. But for this one, when I move on to the second derivative, I have to write it like this. So, can anyone differentiate this for us?
12x2.
Excellent. Now, let's differentiate this, which is differentiating this. We bring down -2. What do I write?
It'll be plus 6x negative 3.
Excellent. You can, of course, rewrite it like this. We can keep it like this. We can keep it like this. They're both okay. Okay, so here I also have 10 on 171. Let's see what was that. 10 on 171. Yes. And this is page 7. 10 on 171. 10, 10, 10. Yes. So y equals 8x squared minus 6, everything raised to -40. We're asked to find y prime. Differentiate or one kind request when you write your solutions for the test, do not write anything on the test paper, please. They will shred it. It doesn't get to me. So, and make sure that you don't write on the last tiny little inch on the perimeter, because I will scan these and return them to you, and the edges will disappear or may disappear. So write inside as much as possible. Don't use the last little thing, because it depends. Their papers are a little bit wider. I'm not sure. Sometimes the little things on the sides or top and bottom disappear. Okay, so write inside the paper. So when I scan it and return it to you, you have the entire exam. Okay, can anyone help us with differentiating this one? I also want to get to limits and the rest, of course. Can anyone help with differentiating this function? Please, anyone? At least get us started. What do we have to write?
-40.
Excellent.
8x squared minus 6 to the negative 41.
Very good. Times the inner function prime.
16x.
Excellent. Very good. Okay, so let's look at the rate of change of average revenue, cost, profit. I just saw that I did not select a problem there.
Wait, so is that the answer? We just leave it like that?
You can further just multiply -40 by 16. And that's all you can do. And if you want, you can put this in the denominator. So (16 times -40) and x.
But the second line is okay. That's full credit.
If the problem says fully simplify next to it, then I would do this. Or at least multiply 16 by -40. At least that. And put x in front. Good. I'm trying to find the rate of change of the average cost, profit, revenue. Got it. Page 163. Let's choose a problem. I think we had one for, yeah, so let's look at 55. We're given the revenue as 45 times x to 9 over 10, and that is in dollars. Find the rate at which average revenue is changing when 175 units are produced. The average revenue. The average revenue. So the rate of change of the average revenue. Anyone remembers what is the function called average revenue? How do we get it? Anyone remembers how we get the average revenue? That's it. Thank you very much. So the average revenue is this function, which is 45 times x to 9/10 divided by x. I copy the base, and what happens to the exponents? What is the rule for dividing two exponential notations with the same base, different exponents? So this is 9 over 10.
That's right.
Yes. Thank you so much. From 9 over 10, I subtract 1 to get -1 over 10. They want us to find the derivative of this function. So r of x over x prime equals. Can anyone give us the derivative of this function? And that would be the rate of change of the average revenue. We had examples with the cost in class. So can anyone differentiate? Can anyone help with the differentiation of this? Anyone I haven't heard from, please. Anyone, please. We still have a few. We still have limits to talk about. We still have domain, compound interest, and piecewise defined functions. We want to finish all these. Please, can anyone tell us? Can you tell us what to do, at least?
Do we have to take the derivative of x raised to -1/10?
Good. So how do I proceed? Correct. Yes.
So I'm not sure, but I think it would be it would be 1/10.
Yes. -45/10 times x to which power?
Raised to
What will you do? Don't give me the final answer. What will you do? What is the process?
I would subtract it by 1.
Exactly. -1/10 minus 1 is -11/10. Brilliant. Thank you so much. Good. So this is the function. And now we have to plug in 175. So we will replace this by 175. Careful how you do that, please. So we have in parentheses -45 divided by 10. Okay, I could have written -4.5. Same thing. And then multiplied by 175 power. I always use parentheses. I shouldn't say always, but most of the time. Divided by 10, which is still -1.1. I didn't have to do that. It's up to you. And that's the answer. So it's decreasing 0.0153 dollars per unit. So careful how you enter in the graphing calculator. Okay, perfect. Now I would like to look at the piecewise defined function and then look at, I don't think that compound interest and domain, but let's do it. So we have, okay, piecewise defined function, 70, I think I'm on page 8. Yes, I am. Okay, so 70 on 23. So here's the function, 70 on 23, 23, 23, 21. Okay, here it is. So we have g of x is 2x minus 3 for x less than 1. It's 5 for x equals 1. And it's x minus 2 for greater than 1. Please remember that you have to change this into -infinity to 1, and you have to change this into 1 to infinity. What is the domain of this function? Looking at this, can anyone give us a domain? Can anyone give us the domain of this function? Thank you so much. Great job, thank you. So remember, 0 has to be in the table always. Even if the function is undefined, we write it's undefined, but it has to be there. So at 1, I see 2 parentheses and 5 right under 1. On this piece, I'm using 2x minus 3. On this piece, I'm using x minus 2. For x equals 1, I have 5. I plug in 0, I get -3. I plug in 1, I get -1. I plug in 1, I get -1. I plug in 2, I get 0. When I graph, you do not have to do this. I'm just making a point. because I don't want my students to graph something like this. If you do graph something like this, I can't give any credit, because this is not a function by the vertical line test. So I'm going to use 3 different colors. So 0, -3 is here. 1, -1 is here, but it's an open point. That's it. I'm done with this. I graph 2x minus 3 with it. Now I'm going to use this and put 1, 5. That's the color for 1, 5. And I have another one, 2, 0. And it's starting at the same point, but still open point, because otherwise it will not be a line, a function. So here it is. So the function is discontinuous at 1. It has a removable discontinuity at 1. It's continuous everywhere else except at 1. It's differentiable everywhere else except at 1, because it's not continuous. And the range is everything. If I want to write the range, I'm asked to write the range, I will write -infinity to infinity. Again, you don't have to have 3 colors with you, but I just want to point out that at any point in time, I draw a vertical line, it will hit the graph or cross the graph in only one point. If you extend this line here and you extend this line here, it's not going to be a function. Although how many times I say it, I will still see it. So that's why I'm trying to avoid that. Okay, compound interest, 34 on page 11. 34 on page 11. Let me know if we still need to do this. This is algebra. So 34 on 11. We are given a deposit of $1,000 at 5% and for 4 years. And the interest is compounded quarterly, let's say. How do I determine the accumulated value? I want to find the accumulated value. What is the formula for the accumulated value? The formula for the accumulated value, please. Can anyone give us the accumulated value formula? No one?
Isn't it like P parentheses 1 plus 0.05?
Yes. Yes. And T. Very good. So it's 1,000. 1 plus 0.05 divided by 4. Everything to 4 times 4. 4 times 4, 16. And you know how to plug this in the graphing calculator and get the answer, right? Yes? Is that a yes?